Alright, time for another DraftScience video presentation. um, Sort of disabled version. Who knows when it gets to be public because Verizon crashed my internet. They do this stupid thing where you sign up for a program, it lasts a year or whatever, and then they start increasing the prices, right? So eventually you have to say, oh, screw this, I'm paying twice as much for my internet. So, and every single time I have to go through this process, they screw something up in some frickin' manner, and it's just too stupid. So they're supposed to be upgrading my service, and what do? They kill it, which kills my phone, kills everything, and you're just like, how, this is like the thing they're not supposed to do, like burning down my house. Next to that is you don't cut off my internet if you don't have to. And it's just like, anyway. I mean, you just wonder what kind of, well, whatever. I won't bother wondering. But yes, I would really like to talk to the technician who hit these buttons and couldn't figure out that, that didn't work. Anyway, irritating. So we'll do some Feynman because it gets to the core of this whole thing is this Feynman attitude. So even the title, probability and uncertainty, as if the subject is probability and uncertainty when we know the subject is how does a roulette wheel work and how do dice, when you throw dice, what really happens? Do the dice do anything mystical, or is it really that you're just creating so many variables that it sort of randomizes the outcome because there's so many variables controlling the dice? And each, you have 1,000,000 variables and you change, 500,000 with every throw. And, of course, by doing that, you're going to change the outcomes. So, and then it says the quantum mechanical view of nature. And, those are nice words, quantum mechanical. There's nothing wrong with those. I mean, the idea that it's discrete bits of mechanical stuff, little bits of mechanical stuff that's running the universe. But that's not really what they're saying. What they're saying is it's a mystical, randomizing God that's, screwing with the universe. It's not mechanical. It's spontaneous and fun. The fun view of nature or something. It really is the mystical Star Wars fantasy reality. And instead of the, yes, we we really did do our jobs. We analyzed everything carefully. Oh, I don't want to do that. Wrong button. Almost pressed. So it just throws you off. You can't do your regular routine. It just, I am a creature of habits, and I don't like my habit being disrupted. So, so let's play some of this. I was going to play it in, the other form, and then the video's a little better quality, but, can't do it now because Verizon is stupid.
In the beginning of the history of experimental observation or any other kind of observation on...
So let's understand, in the beginning they had some right ideas. They figured out some stuff like, well, you got to repeat these experiments because some guy does something in his cave and, it just happened that one time, and it was, because he happened to have the right humidity and the right this, and there was conditions, and he screwed up the experiment in some way and cheated. He mixed too many chemicals, blah, blah, blah. So you got to do this repeating thing. And there's a certain caution there has to be about what experiments you're going to let into, the ones that are valuable, the ones that become facts. Okay, so you got to be really careful about your fact pool, and you got to keep it clean. You don't want any mystical stuff in there, any walking on water stories. But that's not what these guys did.
Scientific things, it's intuition.
So intuition is past experience. That's all it is. And so, that's nice. But the scientist knows, I got to be a little careful about that. So again, it's another cautionary note. Intuition is fine. Shortens the process sometimes when you know what failure, when you know what will add up to failure, recklessness is going to make accidents, lots of things. So you can use your intuition to know where the thing went wrong or why it doesn't quite fit or why this is off or why something else. But it's really not, the whole point is not to be fooled by it. Seems like isn't is like. So that's the part, that's a big one. So repeat experiments. Seems like isn't is like. Got to be careful of that one. Lots of things can look something a certain way. Just because they look like it doesn't mean they is it. Like panda bears or raccoons. They're not bears. That kind of thing.
It's really based on just experience with everyday objects that suggest reasonable explanations for things.
Right, but the scientist is supposed to know not to be fooled by that. That's the whole, that really is, this is, they talk it and they don't walk it. And that's the clear thing here. They talk, be a scientist, and they walk, be a religious kook.
But as we try to widen and make more consistent our description of what we see, as it gets wider and wider and we see a greater range of phenomena, the explanations become what we call laws instead of simple explanations. But the one important odd characteristic is that...
Yeah, well, some things you figure out and they're solid, and you can write them down in permanent ink, and you can even carve it in a piece of stone, and because the rule is so consistent. But, like the one of, energy can never be created or destroyed, there could be a catch to that, in the sense that you do have something like gravity that you haven't quite explained yet. And maybe gravity is the one case where you actually are consuming some of the energy's heat to create gravity. I mean, the forces are in fact slowed down because they have to push matter, and by doing that they create a deficit, on the inside versus the outside. The inside, where there's lots of matter, is creating a force deficit because the force is preoccupied moving little bits of matter. And that's why you have the phenomenon of gravity. So if they would have thought through this a little bit, like I said, it is careful. You got to be careful. That's all this is about. You write something in stone, you should be sure you're right. And you should always just put there, well, until we need have cause to say it's not a perfect law. Yes, it's a law outside of everything that isn't applicable. I mean, you figure out that the world is different in water than it is in air, and it's different in space than it is in air. These are all different places, and they have different conditions. So you don't write a law that says, well, we can write a law for every single circumstance. Well, that's a little bit dangerous.
They often seem to become more and more unreasonable, and more intuitively far from obvious.
So I would change the laws to say, okay, they're worried about a lot of certain things at one time in history, and then later on you kind of evolve and you figure out, though, oh, no, what's the really important thing? The real important thing isn't conservation or this or that. No, the important thing is that all the forces are moving the same speed. And so maybe instead of saying the speed of light, you should be calling it the speed of force. You get plus and minus wrong, you should fix it. Those are the important things.
To take an example is the relativity theory, in which, for instance, the proposition is that if you think that two things occur at the same time, that's just a subjective opinion.
So again, it's not a subjective opinion. What you know is that it's observationally corrupt. That we know that you have to be careful how you're viewing it, and that the facts have to have your viewpoint built into them. You have to build your viewpoint into the facts before you decide what actually happened, before you try to deduce the right answer. There is a right answer. There's not, I get to make up a subjective opinion from different perspectives. No, there's an actual correct way to describe the circumstance, and simultaneous does happen in the universe. It's not subject to opinion. It's a physical event that takes place, and yes, people can be fooled by their perspective because their perspective isn't giving them the correct information. It's giving them a distorted view because the distances are different and the information comes from different distances at different times. So this we can all understand. There is no valid subjective opinion. This isn't an argument about which subjective opinion is valid. It's an argument about understanding that subjective perspectives are tainted, and that you have to understand the taint. You have to understand you're wearing rose-colored glasses or pink glasses or blue glasses or green glasses, and so then you understand, okay, I'm wearing a pair of glasses that's blocking a certain bit of information, and I have to understand that that information still exists in the reality. That's all it takes. But they can't even say this stuff right. They can't even explain the fact that perspective doesn't change the facts. It's a description of distortion in how you're viewing the facts. That there's nothing valid in perspective. There's only something valid in the sense that all perspectives provide information, and if you know the information is skewed, if you know your viewpoint has crooked, then you compensate for the crookedness.
Else would conclude that those two events, one was before the other, and that simultaneity is merely a subjective impression.
Yeah, so it's just a silly statement. He didn't say it very authoritatively because I think he's sort of choking on the words while he's saying it. Of course it's not a subjective opinion. The actual physical universe did something. It's in 3 dimensions and you have skewed views of it. You can understand that your skewed views will produce different interpretations of the facts. But the facts themselves can be understood to be real. Okay, they're not subject to your subjective distortions in perspective. Jeez. I mean, these are the ABCs of science, really. This is another one of these seems like isn't necessarily is like. Bingo.
Now, there's no reason why this should be otherwise, really.
So there is good reason that it shouldn't be wacky and silly. There's good reason to understand that the universe isn't more than one thing at the same time. That different descriptions of the same reality are what's called contradiction. And contradiction is one of the things you can write on a stone saying contradiction is always troubling. I should never be untroubled by contradiction. It doesn't mean that contradiction is never resolvable. It just means that if there is a contradiction, you do need a solution to it. It's evidence of a problem, and it's always going to be evidence of a problem, and so you really should be able to wipe it off. I mean, that is, explain the contradiction, explain why the two perspectives are different. So understanding that the two perspectives are not compatible in the sense that they are not, they're either both wrong or one of them is right and one of them is wrong, but you can't have them both right. They're not both true descriptions that they provide, complete and accurate. They're not going to be that.
The things of the direct everyday experience involve large numbers of particles or involve things moving very slowly.
Right, so we understand this is the whole point of physics, right? Everybody understood that hundreds of years ago. This is difficult. This isn't going to be easy because the big stuff is really big and really far away, and the little stuff is really, really, really tiny. And it's really, really hard to see any of it. And so it's impossible to see in the sense that we can't even throw radiation at it and have any hope of getting any valuable information back. So some of it's just overtly impossible to see, to watch in any kind of indifferent, passive way without interfering with its progress through space. Those are just facts. I mean, those are ones you just accept. And you understand that your task is difficult and you have to be careful. And instead, they just jump to conclusions. So even though they have plenty of reason to pause and be careful, they understand the reason to be careful. They just get in the car and just step on the accelerator and don't pay any attention to what that little meter tells them.
Or involve other conditions that are very special and represent, in fact, a very limited experience with nature. It's a small section only that one gets of natural phenomena from a direct experience.
Right, so he's conceding that this isn't that easy and we have to be careful. I mean, he doesn't say and we have to be careful part, and that's the biggest part missing, right? So it's difficult, and he's not recognizing that the difficult means caution, because you can make a mistake easily. You can miss-see it very easily, very hard to see, very far away, very, very, very blurry, very everything. You got to be very careful before you draw conclusions. And they were very uncareful.
It's only through the refined measurements and careful experimentation.
Okay, so that's the key words, right? See, sorry about the, yeah. It's Linux, it doesn't do the video driver perfect, and you end up with this crap. It's just too big. Bah! Okay, back. Yeah, it's just a little time shift. Everything going wrong kind of period. So, lost a little bit. So I think where we left off was you're supposed to do this careful experimentation thing, and they clearly don't do that. It's clearly a missing element from this physics. They have lots of these elemental experiments that create these nuances, and instead of picking it apart, instead of taking the ferrocell apart and looking at the fluid under the microscope and doing all this stuff that they should do, they don't do any of that. And they just assume there's magic. They don't have any curiosity. The magician hands them the hat, and they go, ooh, this is the hat where the rabbits pop out. And they don't do any careful experimentation to see if it's got a flap in it, the table has a rabbit in it. No, they don't bother with any of that. And that's a gigantic omission. Very unscientific.
Now we can get a wider vision, and then we see unexpected things.
So again, the idea that you would sometimes see something that doesn't make sense is, yeah, okay, that's going to happen. Now and then something weird will happen. It's not going to be a pig flying, though, right? It'll be something that looks like a pig flying, but it's not really a pig flying. It'll be from a distance. That's what it looked like. All these conspiracy theories bring this up, right? Because you can show a picture of the airplane going into the building, and from one specific camera angle, you have a certain, it looks like there's a bomb on there. No, it's just a shadow on the plane, And all this can be fixed with just, scrutiny. A proper amount of analysis, and physics just doesn't want to do any of that detailed work. They clearly like jumping to conclusions.
We see things that are far from what we would guess. We see things that are very far from what we could have imagined.
Yeah, whatever. You wonder what he's reading, because he doesn't really say what he's reading. So, no, that's not what we see. What we see is a huge amount of consistency in the universe, and only a tiny amount of UFO, film. Of all the film ever taken in the history of mankind, tiny percentage is that stuff, and it's all very suspicious. But yes, sometimes things happen that look funny, look strange. Weather balloons. I saw a helicopter once on a very, very, very windy day, right? And the wind was blowing so fast or hard that you couldn't hear it. So all you saw were the lights, and it looked very funky. But it was just because you couldn't hear the helicopter that it looked strange. There's explanations. They didn't go seeking these explanations. They didn't go saying, look, we know the universe is mechanical. We know it's, running on simple fuel. Why are we jumping to these extraordinary conclusions when there's probably an ordinary conclusion that can be defended, that can be understood?
And so our imagination is stretched to the utmost, not as in fiction to imagine things which are... So
that's the work of it. See, that's the whole thing these guys are supposed to be good at, is problem solving, puzzle solving. There's a maze, and the engineer tells you, yes, there is a solution, and you can't find the solution. Well, you figure out why you can't find it. And in this case, it might be a little tricky. There can be tricks. There can be some subtle trick that says, well, some of the right turn walls can be fake. You can push them in and the door will open. So, some kind of thing. And so you just find the trick. You find the thing that was fooling you, the bit that's missing from your understanding, the part of the model you didn't get right. And then you can understand it. But they didn't do any of this work.
Aren't really there. But our imagination is stretched to the utmost just to comprehend those things which are there.
Okay, so all we know is there is the results. Okay, we see the effects,
And what we're trying to dissect are the rational causes. And again, they're jumping to bizarre causes as being the answer, just like a religion. Going with this extraordinary story of this God soap opera that's taking place. The real primitive religions were, it was a soap opera of the gods. Silly answers, not not even close to. Let's try to find a reasonable reason to understand what's taking place here, and not even recognize the obvious stuff that's all around them, in terms of getting the impression, the fact that so many of the other mammals have so many of the features we have. Why wouldn't you think maybe the same process is making them is making us? And the whole idea of just being able to figure out, even watching humans, that certain features are bred by the humans. Evolution isn't that. It's almost like an easy default to fall into without even having any big amount of evidence. Again, Darwin's grandfather believed in evolution. He didn't even need almost any of the scientific evidence, because it just fit with his just perception of the world that obviously this breeding thing works. We've made roses and we've made all kinds of things by selectively breeding. Why wouldn't nature be able to make them without selecting by some other process of selection?
It's this kind of a situation that I want to talk about tonight. Start, for instance, with the history of light. At first, light was seen to behave, that would appear to behave very much like a rain of particles, of corpuscles.
So again, it could be that everything seems that way because everything's pushed together. So we could understand gravity as the same sort of rain. You can understand that and that the heavier the object is, somehow collects more of the rain, and then it hits the ground harder because it's collected more of whatever that stuff is that's pushing everything in. So, and yes, light has every appearance of being stuff that flies, and you can put your hand up and block it, and all of those things. So yeah, it fits. It fits with the idea of spit or some other mechanical stuff that flies off of something, and that you can move it, and that you can change where it goes.
Like rain. Bullets from a gun, same idea.
So this is the part where it fell apart a little bit, and the first. See, I don't know, if I'd never had the prejudice of ever listening to physicists, then maybe I wouldn't have fallen for this assumption that, oh yeah, the photon is a thing. It's a discrete clump of photon. And not realizing, then because I did in the past try to imagine photons as filling the whole frequency, like somehow the whole thing would be there, and the next piece would be right up next to it, and then the next piece would be right up next to it, and that these things would be called photons, and they would have a frequency. But that's the wrong way to think about it. The empty space is the piece. It is bullets moving in a frequency. The frequency is in the things inside the photon. The photon is made of more than one thing. 3 bullets at a frequency. There, that is received as a photon. Maybe it's 4. Maybe it's 5. Maybe it's 500. I think it's more likely it's going to be some number like 2 or 3. But regardless, that's what a photon is. A photon is a pattern conveyed from one place to another. It's a bang, bang, bang. That's it. That's a photon. Bang, bang, bang is blue. Bang, bang, bang is red. So it's particles, but it's not a particle. So that's the big mistake. Is we hear the word photon, we're thinking of something, and it's just like an atom. An atom isn't an atom, right? Our first impression was, oh, we found the small thing, it's an atom. And then we found out the atom's made out of components. Well, the truth is we said photon, and we said it a little too soon because, the photon is really made out of components. And the components are the elements. The components are the thing that is the electron and proton, so to speak. The elemental bit are the little bullets, that make up the photon. The little corpuscles of energy. the particles. So again, the photon is a composite. It's still particles. It's just a composite of some smaller particle than photon. And then that explains the whole polarization problem and all these other problems I've pointed out, that obviously a photon that has huge polarization, the wavelength is proportional to the polarization. A single photon can't possibly interact with an electron. But a single bullet, a single piece of a photon could.
Then with further research, it was clear that it was not right, but that light actually behaved like waves.
So it wasn't clear, and so when they say further research, that just means that people like Huygens speculated that you can use these wave theories to explain things like refraction and the speed changes and blah blah blah. But wave theories are still subject to being just called particle theories, because again, waves of what? Waves happen in mediums. Waves are an event. Waves aren't elemental. There's no elemental wave. I mean, what are you going to make the elemental wave out of? Jellyfish and seawater? Then you're still stuck with where'd the jelly come from and where'd the seawater come. What is that mechanically? So you're still going to have to explain what that substance is, what this ether is, and you're still going to be stuck inventing particles again. So particles can wave, waves can't particle. It's clear that waves are an emergent property. They're something that happens in complex systems, not in simple systems. They're not elemental. So wave was always a bad explanation, in that you knew if you're going to say it's a wave, you're going to have to explain what's waving. There is an answer to the question of what's waving, and and it's still missing. And it's a big miss.
Like water waves, for instance. And then in the 20th century, on further research, it appeared that light actually behaved in many ways, again, like particles.
So again, further research just means an experiment comes up. And again, it was very fluky stuff. So again, the part of what emphasized the waves in the 1800s was the Young experiment. As I pointed out, the Young experiment was wrong the day Young drew it. The geometry isn't right. It doesn't match the pattern. It won't get you the right answer. He has the sources in the wrong place, the center of the openings. The center of the opening is not the wave centers. Mathematically, it doesn't work. It won't get you the right answer. So, they already had the fact that it was wrong 200 years ago, and here it is 200 years later, and they still haven't even admitted they made some wrong assumptions. And then on here he's talking now with the photoelectric effect, which can also, you could say, okay, it proves light's a clumpy. But the fact is what you can prove is that our only way of detecting light is with a clump detector. We can only detect clumps. So, of course, anything we're detecting with our clump detector is going to look like a clump. Duh.
In the photoelectric effect, you could count these particles. They're called photons now, and so forth.
So again, they're called photon, but the language was already prejudicing a conclusion that closed doors to understanding that, well, what if the frequency isn't what the photon is made out of? It's pretty hard to make something a frequency. It's hard to say this is a frequency. This is 500 nanometers. It just doesn't make much sense. And especially when you know that some of this radiation comes in 2 mile or 5 mile or 10 mile lengths. How can the ton be 10 miles long, or be, like an X-ray be, 1/10 of a nanometer? How can it go from those huge extremes in size when, the more logical conclusion is that, yeah, just like we can shoot bullets once every day, or I could go outside and shoot a bullet once a year. I can change the frequency just by changing the period of how often I fire the gun. And likewise, that's a way of understanding what a photon is. It's just a period between clumps of stuff, and you're just measuring the frequency. You're just measuring the pattern. All of that's thrown out the window as soon as you start saying photon, photon, photon. As soon as you start narrowing it and saying it can only be a solid object, well, then you've already broken a whole bunch of theory that might have answered the question. And I would argue it would have answered the question if they had thought of it. But they didn't think of it. So they assumed and just closed the door and said, we thought about it for 5 minutes. In 5 minutes, we couldn't come up with an answer, so we decided to go with the UFO explanation. And that's really what it comes down to. It's really that superficial. They gave it very little thought. Just like the conspiracy theorists with their inside job theories, they gave it very little thought. All they needed is one little thing, the outside of the building didn't fall down at the same time as the inside of the building. They don't want to hear about that. You just look at the picture, and the picture says it fell down too slow. Well, that's because the picture isn't telling you the truth, because the inside of the building fell at the right speed. The outside of the building, the facade, it crumbled much later.
Again, electrons, when they were first discovered, behaved exactly like particles, bullets, very simple.
They always will and always did and always have and always will, and so there's nothing else changing that. So the story of electrons where they've said they're behaving some other way, no, they always behave like particles. They always do. A single electron always behaves like a very single solitary object. It doesn't have any of the features that photons have. And it's only in group behavior. So again, they can't make a single photon do something wavy.
Their research show in electron diffraction experiments and so on that they behave like waves.
Okay, so they don't really do that. They don't individually behave anything like a wave. What they're talking about is they're reflecting it off layers of material, and the electrons hit different depths of the layers, and then they reflect at different angles. But the single electrons are clearly doing single events. It's just clear that it's just a matter of probability whether it's like you jumping there's 4 skateboards and you jump in the air and you have to land on one of them. Well, you might not predict perfectly every time. So one time you might land on the one that's furthest away, and the next time you might land on the closer one. You might land on this and might land on that. And the electron's doing the same thing. Sometimes the electron goes through the first layer of atoms and hits the second layer. Sometimes it goes through the second layer and hits the third layer. That's not stuff we can't understand. The individual electrons aren't doing anything wacky. It's just that as a group, the odds are just like the roulette wheel. Sometimes it'll be a 2, and then the next time be a 42, and 42 on the wheel, but 22, then be a 7, and then a 14, and every time it's going to be another number, and
And as time went on, there was a growing confusion in the question of how the things really behave.
So this is the word, right? So yes, it's a little bit of doubt thrown in. And what has happened in the past when you've had this question? Well, in the case of plus and minus, you figured it out pretty quick that, Benjamin Franklin guessed wrong, so let's fix it. No, they didn't fix it. In the case of the 50-year argument over what the nature of energy is, and instead of fixing it, they all just gave up and said, let's just go our own way. If you want to believe in momentum, believe in momentum. If we want to believe in kinetic energy, we'll believe in kinetic energy. Now, even though they get different answers, they answer the same question with a different answer. Clearly not right, clearly a contradiction. They pretended everything's fine, And the same thing happened here with wave-particle duality, just a complete cop-out. They know this can't be both. There's a reality here somewhere, and there's reasons for it. And again, the simple logic is, yes, particles can act like waves. Waves can't act like a particle.
Waves or particles. Particles or waves, but everything looks like both. Now, this growing confusion was resolved in 1925 or 26 with the advent of the correct equations for quantum mechanics.
So this is sort of just talk. He's just saying the Schrodinger equation, which is just probability math. And it's kind of a bullshit statement in the sense that it presumes you have knowledge you don't have. So they have a little forky signal that they use for all knowledge. That is, you have knowledge of all 3 dimensions of space and where something is, and then you just move these changes in its 3-dimensional position. But you don't have answers for any of those questions, so all they're creating is an equality. A probabilistic equation that'll tell you, which which percentage of what you can expect if you do it 100 times or 1,000 times. But it doesn't tell you anything about the mechanism or how it works. It doesn't answer the wave-particle duality question. It doesn't do any of that stuff. So again, it's just, oh yeah, we have an answer. It's not an answer at all. We already know it's probabilistic. Again, I can write a Schrodinger equation for a roulette wheel. I can write it for a pair of dice. I know the dice aren't doing anything wacky. I know they're hitting surfaces, and that'll decide what they're going to show when they land. And it's a purely mechanical process that just has too many variables, so I can't control the variables. So I can't know what's going to happen, but I can know what's going to happen in the sense that I can know after a bunch of permutations what are the possibilities and what are the probabilities. And so all it is, it's a probability equation. It didn't answer anything. It wasn't a solution to anything. Didn't tell us anything.
And now we know how the particles, how the electrons and how light behave.
Right, we know how they behave just by watching them. So we already knew how they behave. So again, this wasn't any new insight. Okay, the pattern was pretty clear. Okay, so it's an overt pattern. And again, they didn't pay enough attention though, because frankly, like I said, I mean, the Young experiment, the Young drawing was wrong right from the beginning. So they had so little attention to detail that they didn't even realize it's the wrong pattern. Clearly, the double slit pattern is completely different than the single slit pattern in the sense that it has critical different features in it, where it's clearly two patterns superimposed on each other. Another statement, another fact they just tend to ignore. They pretend it's not really there. They pretend the only experiment that actually creates a pattern is the double slit, when, it's really easy to create lots of pattern with a single slit. So all of this is part of the just do a horrible job of paying any attention to the actual facts just to tell a story. And so they're just propagandists because they clearly quote mine the evidence. They're clearly cheating the facts to persuade you that the evidence points to we can't answer these questions. And that gets into the whole Heisenberg thing. Clearly, it's, isn't it kind of a preposterous coincidence that the one place that all this mystery happens, where the universe is all crazy and wacky, is the one place we can't see? Isn't that just a little too coincidental? Come on. I mean, seriously. Who falls for this? The Invisible Man only, he only goes out at night. When there's no lights on, and during power failures. I mean, yeah. Oh, sure.
But what can I call it? I can say they behave like a particle wave, or they behave in typical quantum mechanical manner.
So again, there's no behavior. They have no understanding of any behavior besides the outcome. And they really haven't figured out in any way whatsoever how they get to that outcome. They don't even know what they're starting with, let alone what they're finishing with. And I would argue that there are simple explanations that solve all of the problems and answer all the questions. So all you have to do is view photons as a pattern. And once you understand there's a pattern, it's a really simple pattern, ... like Morse code, that you could just mess up the dots and dashes, and then you could still form dots and dashes at the other end where they would make signal again. So you could throw words in, the words would get messed up, and you'd end up with words coming out at the other side. You can understand how that could happen. So, and that explanation solves all of this mystery. It gets rid of all your duality issues, and it explains what a photon is and why you get a pattern.
There isn't any word for it. If I say they behave like particles, they give the wrong impression. If I say they behave like waves, they behave in their own inimitable way.
So just some sort of mush, it's the magical Holy Ghost, spiritual, they're shamans, that should be a last resort. If you're going to go to the extraordinary explanation, you ought to have extraordinary evidence. And again, they haven't even paid attention to the ordinary evidence. They can't even explain honestly something as simple as two slits in a material. And they can't explain two-slit experiment and do it honestly, accurately. Something that simple, an experiment that has so few devices, so few complexities in it. It's just a flashlight, it's a light source, two little openings, and then a screen to view it on. And they can't describe that simple function accurately.
Which technically could be called the quantum mechanical way.
So again, nothing wrong with the word mechanical, nothing wrong with the word quantum. But they've turned it into, we have to come up with this extraordinarily strange and bizarre, the universe is really messing with the dice. The dice aren't getting randomized by hitting surfaces and bouncing and tumbling. No, they're getting randomized because there's something in the universes that's turning the dice. No. Again, that should be the extraordinary explanation, a last resort. You don't go there until you're really exhausted yourself with your magnifying glass looking for a better answer. And they never pulled out the magnifying glass, and they certainly didn't exhaust themselves looking for a rational answer.
They behave in a way that is like nothing that you have ever seen before.
So he's going to draw it, okay? He's going to, so a lot of it we have seen before. Certain elements of it we see all the time. So again, it's not the outcome that is so shocking, okay? It's their explanation of the outcome that is shocking. It's not the event. The event isn't that extraordinary. It's not a picture of Jesus Christ. It's not a piece of toast with Mary on it. The outcome is just a simple on-off pattern. Okay, it's not all that miraculous. It's just not. It's so elemental and so simple. So but again, the part that's extraordinary is the stuff they've made up to describe the process of creating that terribly simple pattern. And it's a terribly unsimple process to create an extremely simple pattern.
Your experience with things that you have seen before is inadequate.
So again, it really isn't. And you could understand that if I did just change these descriptions a little bit, if I just change the bullets, I change the photon into, instead of the photon being a thing, I recognize that the photon is a pattern, and that all I'm really saying is can I change the pattern? Can things be distorted by changing their timing and space, but I still get pattern at the result. So it goes into the process, into the challenging mechanism, okay, the obstacle course. And after the obstacle course, it's different. Okay, one of its left shoe is on its right hand. The things are in the wrong place, but it's still the same parts. It's still the same pieces. And all you've done is realize that, yes, through the interaction, it got beat up a little bit. Something changed. But it's not fundamentally different.
Complete. The behavior of things on a very tiny scale is simply different. They do not behave just like particles.
All right, again, by different, he means holy. He means spirits. He means voodoo. He means it's all kinds of wacky crap is going on there. There's all kinds of hands of God fiddling with it. So that's all he's saying. He's saying it doesn't do what the rest of the universe does, okay, which is, cause and effect. No, cause and effect is somehow broken. All we get is effect, effect, effect. And it's, the causes are some sort of magic. And that's an extraordinary claim. It's incredibly unscientific. And the fact is they really have no good reason to resort to that as an explanation. They have no defense for doing it, except they were religious people. They wanted it to be true. That's the only thing you can come up with, because it's so unscientific and it's so hostile to logic, in that, again, it's just a coincidence, that their God also has to work in mysterious little secret ways. You can't do anything out in the open. You never can. The miracles are never, rational miracles. Like you actually grew somebody a new arm. No, God can't grow you a new arm. Yes, he can make all your cancer disappear, or he can make you feel really good. Okay, but he give you superpowers that you feel his power, but he can't do anything obvious. Isn't that just a little bit too coincidental again? Oh, that God has the special rule that he can't do a miracle that's obvious and rational. Well, their magical superpowers that they've given these little bits have the same stupid rules, the same stupid conditions that somehow they can't make anything happen in the world we can see. Oh, bullshit. It's just a rationalization, just nonsense. It's illogical. A sensible, rational, smart person should not be fooled by a God who can't grow somebody a new arm.
Do not behave just like waves. Atoms do not behave like weights hanging on a spring and oscillating.
Right, well, nobody should think they are. And nobody should even accept these like, again, it's always these conclusions about what reality is has been decided by 15 people. 15 scientists throughout history have written all the rules. And why should we think just those 15 people knew what the hell they were talking about? I mean, the Bohr model, the whole spinning electron crap of solar systems. You can understand that atoms are constantly moving if you understand the universe is full of energy. Right now, I'm getting hit by light from over there and light from over here and this and this and this. You could just understand if the real universe had a lot more of this energy in it, that I couldn't see. I mean, understand the light you're seeing is only the light coming at a straight line into your pupil. The actual light in this room is intense because if you added it up at all the locations it's landing on, it's an intense amount of light. Tremendous amount. And that's just the visible stuff. That's not counting all the radio waves and the cell phones and the microwaves, all the crap that's flying through this room right now. And that's not counting all the stuff the universe might be throwing at us also. The stuff we don't see. That's the logical explanation.
Nor do they behave like miniature representations of the solar system with little planets going around in orbit.
Okay, so again, he's just arguing against conventional physics, which is ironic. So he's basically negating all of his colleagues' perceptions now. He's not just debunking every other theory that somebody might invent. He's debunking the ones the other physicists believe in. He's telling them that their truth isn't truth either. Because the only truth is the Feynman magic truth. Nothing is real. Everything is just spontaneously spontaneing. The universe isn't made out of physical things in 3 dimensions. No, it's just some sort of silly drawing on, some sort of God's piece of paper.
Nor does it appear to be somewhat like a cloud or fog of some sort surrounding the nucleus.
So again, that was clearly what other physicists believe and still do believe. And now he's saying, no, none of that's true. It's just probability. And it has no reality until somebody views it. Somebody does this, I'm going to watch it. And then all of a sudden it decides to be one place because I decided to detect it. When I could argue the universe is detecting all the time. I can't sit here and I'm not getting detected. I'm getting detected by 1 billion photons every second. I'm completely incapable of being undetected, and so would a single electron in this room. If I had a single electron sitting right there on my finger, it's detected. Okay, it can't sit there and say, I am hiding for everything. Nobody knows where I am. No, it's being viewed right now by everything in this room. And because this battery is reflecting light onto the little electron, because this battery doesn't have an eyeball and a pupil and a brain to say, oh, I saw it. It doesn't matter. It's looking with the same amount of energy. The energy coming from all the things without eyeballs, it's the same exact energy as the energy going in my pupil. It's the same detection. Now, are you really going to say that the little tiny electron can figure out whether it's the photon that hit it was one going into a pupil? And I'll only be worried if it went into a pupil. That's the only kind that de-entangled me. De-superimposed me, so I had to show where I actually am. I mean, this is, again, I can tell you that this is what they believe, that it's this silly. They actually think nothing is real until something perceives it in some way, And like I said, every piece of evidence is that everything all the time is getting perceived. This thing sitting here right now, this flashlight, it's the force of gravity is pushing it into my hand right now. It's being detected by gravity. How does it evade gravity? How does it pretend I'm not going to get detected? It can't be undetected. It's baby talk.
It behaves like nothing that you've seen before. Well,
so again, what he's directly saying to you is it behaves in a mystical, magical, phantasmagorical, silly, spiritually, whatever, bibbly, babbly, boo, Tinkerbell, magical way. And we have to believe that because the evidence is just overwhelming. We just can't evade the piles and piles and piles of super great evidence that 9/11 was an inside job. And that's all this is. This is just a conspiracy theory.
One simplification, at least electrons behave exactly the same in this respect as photons.
So let's understand they don't behave exactly the same in any way whatsoever. The electron experiments are completely different. When he draws it, they won't be drawing the electron experiment. Not a single detail will be the same. Completely different experiments in terms of how it's contrived. The electron is completely opposite of the idea. The photon is supposed to be randomly going in all directions. The electron, they go to a huge amount of trouble to force the electrons to be very precise in their path. So it's just a fraud. This is nothing to do with the truth. The experiments have no similarity to each other at all. All right, and so this is just part of the fake lie of just arguing that somehow that it's something like the same. It's not anything close to the same. The conditions of the experiment are nothing like each other. How the experiment's done, nothing similar. I mean, it's just, you can only call it a lie.
That is, they're both screwy, but in exactly the same way.
Yeah, so they're not screwy in the first place, and it's not the same way. So the screwiness, if there was something that has to be accounted for, isn't the same, and they're certainly not in the same way because the experiments are completely different.
How they behave, therefore, takes a great deal of imagination to appreciate, because
so what it takes is you have to actually look at the experiment and analyze it and be accurate in first recognizing there's two different patterns, the single slit and the double slit, and then you have the multi-slit, the diffraction gradient where you have another pattern. So you have three different patterns to account for. Not the same pattern. Okay, they're not the same. They're very different, very distinct, very identifiably different. And instead of paying any attention to those details, they just pretend it's all the same thing. And it's somehow all caused by the same magic beans.
because we're going to describe something which is different than anything you know about.
Yeah, you're going to describe voodoo. So we're all going to take a lesson in voodoo. Our bone throwing, predicting the future by throwing bones and pieces of gristle and whatnot. This isn't science. This is junk. This is mysticism and bibble babble. You might as well be saying, if you bang your heels 3 times and say there's no place like the hookatorium, you'll have a fun life.
This, in that respect at least, makes this perhaps the most difficult lecture of the series in the sense that it's abstract.
In the sense that, frankly, yeah, it's so silly and so preposterous, and then you're going to explain it by cheating the truth so egregiously, and then try to sell us on this conspiracy theory, defending an irrational god of random fiddle-faddle. I mean, it's just horrible science in the processing of it, and it's horrible science in that the conclusion sounds just like religion. Why would I? Yuck.
In the sense that it is not close to experience. And
there we go. That should be the thing. It's just, yes, that's right. It doesn't have anything to do with all the real physics and the real physical universe that we are able to videotape. So all the stuff that we actually do get a chance to see doesn't do any of this silly crap. So why are we assuming the stuff that's hard to see is where all the silly crap is happening? Again, it's a catch-22 kind of horse shit. Oh yeah, I'm talking to the people from the future, or I'm talking to people in the past. I'm, blah 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 blah. But I can't predict lottery numbers because that's against the rules. It's just such crap.
I cannot avoid that. Were I to give a series of lectures on the character of physical law, and to leave out from this series the description of the actual behavior of particles on its...
So let's understand, it's not the actual behavior because he doesn't know how they behave. He doesn't understand it one iota. He doesn't know what a photon is when it leaves. He doesn't know how it's created. He doesn't know what it does when it's flying through space. He doesn't know what it's doing when it's interacting. He has no clue about any of this stuff, and he's ignored all the most important details that would give you some clue. Like if you pay any attention to the math and the geometry, you find out that it's the surfaces where are the point sources. The surfaces are where the funny bits happen. So all the fringe pattern, every bit of the fringe pattern can be understood as coming from a surface. That's the math that works. That's the geometry that predicts the right pattern. If you want to predict the pattern accurately, you understand that the point source, the source of your wave or whatever you want to call it, has to be the surfaces. So right there it's telling you something. Oh yeah, that would sort of make sense, right? The surfaces are what's screwing things up. I can understand how surfaces could do that. Things could bang into them. It could disrupt the shape or the function of the photon and cause this change. But they don't do any of that. He doesn't emphasize that fact. He doesn't illustrate and point out to you, these surfaces are really the point source. So all of this funky stuff that happens, all the light goes straight through. No, that didn't have anything to do with the surfaces. And that's not doing anything funky. All the stuff doing the funky stuff, yeah, that was all stuff you could draw the nice straight line right to the surface. All that stuff came right from that point, the surface. Emphasizing that would make this story a lot less believable.
Small scale, I would certainly not be doing the job because this thing is completely characteristic of all of the particles of nature.
Okay, just said, no, it's not characteristic of all. It's not characteristic of the screwdriver. It's not characteristic of me. It's not characteristic of a speck of dust. It's not characteristic of anything we can see. It's not characteristic at all. So again, that's just propaganda and bullshit. And the fact is that the experiments, to be able to see this effect in other particles and other things, they have to change the experiment fundamentally. It's not anything like the same experiment. So they're forcing it to confirm. They're forcing it to do something similar, and it's only grotesquely similar. I mean, it's not similar in any kind of identical twin kind of way. No, it's similar in that, maybe it weighs as much. But in no other way, it's a walrus and a elephant or something. They're just not the same animal.
Universal character, and it is, if you want to hear about the character of physical law, essential to talk about this particular aspect.
No, so it's not essential, and it's their conclusion. And it's their product. It's their Christian story. It's their religion. They have a story, okay? All the other religious kooks could have a story too. And if you really don't care about scrutiny, and if nobody else is, if you're going to apply no scrutiny, they can get away with it. Now, of course, like I said, they'll ridicule the Muslims. They'll ridicule the believers in a tree god. They'll ridicule the people who believe in abominable snowmans or something. Abominable. But they won't apply the same scrutiny to their own wacky, silly theory. And it's no more evidenced and no more based in reality than any of those other wacky theories. It's just as flawed and clearly flawed in the sense that it's full of just propaganda and lies. Just full of experiments never took place, full of misinterpretations and perversions of the facts. Ignorance of the facts.
So it will be difficult. But the difficulty really is psychological and
Yeah, no, the difficult really is it's a terrible theory based on absolute mush, terrible scientific process. We really just didn't give a shit about the details. We don't give a shit about the facts. We didn't spend any time really thinking about it. It just, a few of our little top people decided to tell this silly story and everybody else just tells it. And that's all it is. It doesn't have any credibility at all. It doesn't show any industry. It doesn't show any hard work. It doesn't show anything like that. It shows a silly little cop-out to a bizarre and nonsensical explanation. Horrible science.
exists in the perpetual torment that results from your saying to yourself, but how can it be like that?
So he's conceding the argument that it doesn't make any sense, it's silly, it's creepy, it's just doesn't fit, it just makes the universe seem like just such a silly, stupid place. But believe it, because we've decided for you. We did all the thinking and we figured out no other explanation could possibly work. Only the ones we thought of. See, we thought of all the other possible theories and disqualified them all. Because we're really smart. We did that favor for you. Now the truth is, though, you can see, and he hasn't paid any attention to the experiment because he doesn't even know what the pattern really is. He doesn't know where the patterns are really formed, how they're formed. Grotesque and egregious errors he will make in his description of what happens. So it's clear that he doesn't have any authority to tell you this, that you don't have any choice but to believe this nonsense, because you can see in his own presentation he has no clue how the thing actually works. He can't get, hardly any of the facts right.
Which really is a reflection of an uncontrolled, but I say utterly vain, desire to see it.
So let's understand where the vanity is. The vanity is in these fucktards who, they get their little Nobel Prizes, all feel big-headed. If I didn't think of it, nobody can think of it. There's no chance anything else could be true but what I believe. I mean, they're the ones full of the vanity. They're the ones who have evaded scrutiny.
In terms of some analogy with something familiar. I will not describe it in terms of an analogy with...
Oh, so of course he does. So that's the joke here. I won't do that, except I will do exactly that. That's exactly what I will do. I will give you a crude, buffoonish version of particle, and then I'll give you a crude and buffoonish version of wave, and I'll disqualify them both by giving them no nuance, giving them no character that could make all the difference. So I'll make them so featureless that they can't possibly be seen by you as what they really could be. So he's just going to cheat them grotesquely and use them as analogies. He's going to straw man the hell out of it.
Something familiar. I'll simply describe it.
No, so he's not going to just simply describe it, because he has no simple description. He has no capacity to describe it, because then he'd be stuck with, well, we send stuff in, I don't know what the stuff is, and we get this thing out, where it's a pattern. And because we're physicists, we've decided that on-off patterns are always created by interference, and nothing else in the universe could ever create an on-off pattern except for interference. There's no other possible way to create the simplest pattern in the universe except by our God must be doing it, creating instant randomness in there. Bullshit.
There was a time when the newspaper said that only 12 men understood the theory of relativity. I don't believe there ever was such a time. There might have been a time when only one man did, because he's the only guy who caught on.
Caught on to what? Again, bent space-time. I mean, time's a function. It's not a destination. It's not a place. The whole thing is wacky, silly, and vacuous as an answer. It's another non-answer to the question, what's causing gravity? Well, fuck it. Let's just talk about the effect. I already know what the effect is. You can draw the effect by, drawing, in 2 dimensions. You could draw it like a well, but I could draw a light bulb like that. You think anybody would believe me? That's how a light bulb works. It's a flower, and the flower just shooting You know, no one's going to believe that. That's not what a light bulb is doing. And because it never went in 3 dimensions, I know that's not what it's doing. It's shooting energy out in all directions. That's what it's actually physically doing. And gravity's doing exactly the opposite. It's consuming energy in all 3 directions. You know, all 3 dimensions. It's a convergence. It's not a bent anything. It's a clear convergence. Things out here all move in towards it. There's no bent anything. And it's not an answer. It's not telling you why. Newton already told you that's what it looks like. Yeah, it looks like a convergence. I mean, Newton could have done this silly idea of, well, yeah, you know, you dent a tablecloth there in 2 dimensions, you made a well, you know. But the reason why he didn't probably do it is because, yeah, it's not a real analogy. It doesn't deal with the fact that gravity's in 3 dimensions, not 2. Bent space time? It's useless mush.
Before he wrote his paper, but after people read the paper, a lot of people kind of understood the theory of relativity in some way or other.
Oh yeah, right. You can't really understand it because all it is some, you know, it's a silly vacuous answer. And then when he contrived the math to make it, okay, the math is just contrived. So it's just a big pile of mush, okay, all to get out some end result gamma number, you know, that really doesn't have to necessarily have to do anything with anything except that we already know, or you might already know, that velocity affects things. So the more velocity you give something, the more it might lose some of its material functions. That's not a huge surprise. Again, I could point out that if I move my hand the speed of light towards you, it'll collect an awful lot of energy by the time it gets to you. And then if I do exactly the opposite, move it away at the speed of light, all of a sudden it's reflecting nothing. And it's become invisible. Now, it hasn't lost any of its mass. It's not that it's not real anymore. It's still real. It's just that you're not going to be able to see it.
But more than 12. On the other hand, I think I can safely say that nobody understands quantum mechanics.
Right, so it's a joke. Ha ha ha. We have a theory so wacky and silly that nobody can understand it, and that's a good thing somehow. No, that's a bad thing. You know, that should be, everybody should be able to say, no, that's not a good thing, Richard. That's a bad thing. All right, because we know the physics always gets simpler going down. We know that when, you know, all these questions will be answered. Right now, biology doesn't have a perfect answer for abiogenesis, you know, the evolution of the DNA molecule, in the sense of it going from just being a single molecule to being a molecule capable of being torn apart and then the copies made and having a membrane around it and all of that. But we know there is a process. We know it's a sequence of events. You know, and those blanks will be filled in, and nobody's expecting those blanks to be filled in with, and then the hands of random God got in there and mushed the DNA up. It went squish, 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 and now that's what happened to the DNA. The random God went in there and went squish, 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 and now we have a DNA molecule inside a membrane. The DNA, you know, the random God picked up the molecule and stuck it inside the membrane. There. We know that's not going to be the answer. You know, but people will buy these kind of silly explanations from physicists because they have, because the physics is small, because it is so hard to see, and that's the only way they get away with it. Because we know we're not going to see that in the biology. We're not going to see chemicals that just pop out of existence and then pop into existence, some new place. We know that's not going to happen. So anyway. All right, probably enough for right now. Yeah, I'm tired enough. So we'll add some more later, or not. See what happens and such.